So bringing it or tying it together again, sort of keeping on the notion of technology, human and nature, as Martha also said, there is a paradigm shift already in the making where we have to reimagine, also like Martha said, our relationship between technology, nature, and ourselves. And why is this important? And how do we go about doing this? Well, Peter Hesseldahl is editor and journalist at Måndag Morgon, where he covers topics like technology and also the future trends that he sees in our economy and society. He's the author of 7 books. His latest book is The Transition to the Future, where technology comes alive and life becomes technology, which focuses on the trends that hopefully he'll talk about shortly. Now, he's going to join us today to talk about a vision for a new economy, an economy that turns the environmental and social challenges we face today into an opportunity. So with that, please say a warm welcome, or I say a warm welcome to Peter Hesseldahl.
Thank you very much. It's a pleasure to be here. What I'm going to talk about are rules of the game. What I do in my work is that I try to identify trends that we will all have to play up against. And I'm trying to look at the ways that the economy is changing towards a new paradigm, some of which Martha has just described, a paradigm which is much more characterized by biology, living systems, ecology, sustainability, those sorts of issues. But first off, I wonder if you were going to mention in the last 3 years, what would be the product that has the most impact on the global economy? And I would say it's not a new iPad or a new iPhone or some fancy digital service. I think this time around, it's a biological invention. It's the mRNA vaccine that has kept the COVID pandemic at manageable levels. And I think that was the first time that we've had a global blockbuster breakthrough based on a very, very deep understanding of biological mechanisms. And I think this is only the first of a number of new technologies that will characterize the economy as we move forward. I think if we look ahead and say, so what's next then? And I think what's next might be something like AI. I don't know about you, but recently I've discovered Midjourney and DALL-E, these graphical tools based on AI that are able to generate quite amazing and prize-winning illustrations just by speaking to them. I think AI will likely, in some form or other, be one of the major contributors to the economy as we move forward. And then what's ahead? Well, maybe autonomous robots, cars that drive themselves, robots like Boston Dynamics robots that look completely like animals or some kind of human, but have a very distinct biological flavor. It's not just old mechanics as we used to see them. Another bit on the future might be that we could see something like artificial meat or artificial dairy that is grown in vats or from cell culture completely without growing the entire animal. Again, these are inventions that are different from the mechanics, the power plants, the computers, the electronics that used to be part of the economy. This is something different because it's alive and it's based on biology. And this is what I think is the new technological paradigm. But this paradigm requires us to think in different ways and describe technology in new words. So I think basically what happens is that our technology becomes alive, like a robot that starts to act like it's living, and you wonder what's in there. Is it alive? Is it conscious? And also our life becomes technology because we harness the power of genes and biology to create solutions that we couldn't create with mechanics or electronics. And the interesting thing about this is that the vocabulary we use to think about this is different. And I think we have to use these phrases to be precise in describing the systems that we will be working with in supply chains, in manufacturing, in our daily use. So we will have systems that will be evolving. We will have machines that are learning. We will have algorithms that are creative. We will have a sense of technology that we're facing, that it is intelligent, it's smart in a way. And it will be gradually so smart that sometimes we wonder, is this thing conscious or not? Is something new actually happening here? And this, again, this is very, very different from the kind of technology that we're used to dealing with and used to creating models on, because it behaves in a very different way when it can be intelligent and evolve on its own. Basically, I think we've been in an industrial age. The industrial age was wonderful. It brought us all kinds of consumer goods. It created great wealth, and it was based on a few principles like standardization, infinite growth, the linear process of just transforming materials and distributing all over the world. But I think a lot of the concepts that are quite fundamental to this way of thinking and producing will have to change, because two things. One is that the next level of value that we want to build the next level of growth on is simply the industrial model is not sufficient. And also because our circumstances are completely different. We can't continue with the old expired model. And I'll get into that in a moment. So basically what I think will come instead is that we will move from a focus on the product, so the industrialized car, to a solution which could be mobility. And let me give an example. The car is the archetypical industrial product, you know, Henry Ford's manufacturing product lines. But today we can't just think about a car. If we want to create more value for customers, and also if we want it to be part of a very complex and integrated global economy, we have to think of something different than just the product, the car. Because a car is basically, you can't just dump a car on the streets. You have to think these days about charging stations. You have to think about regulations. You have to think about supply of batteries. You have to think about a smart car. You have to think about mobility as a service. There's all kinds of new connections and integrated services that become part of the product and instead delivers a total solution. And this solution is not a solution that is static. A solution is something that is created on the fly for somebody who needs it right now. And the solution and the combinations of resources that are used to create the solutions is changing all the time. So I think the model that I think we will see is the platform model. I think we will have a platform in the middle based on digital technology and lots of data. Data about the user's needs in the context that the user is in right now. So it's Thursday evening, I'm in Stockholm, I need to get home. That is a different need from Saturday morning and I need to go to the dump. And also, so knowing exactly what does a user need right now and in this particular context, but also knowing what are the resources available to create a solution that fits the user right now and right here. And I call this instances because it's a solution that only appears once. It might just, that particular constellation of resources and user needs just exists once and bang, you move on. And that's a very, very different way of creating value than the old industrialized way when you created millions of completely identical products. We see this pattern many, many places. We see it in energy now, where it's not a matter of building one big power plant. We are talking about power to X, where we need to weigh the different sources of energy. Solar, wind, is wind blowing? Should it go to hydrogen? Do we need to create fuels for jets? This whole management of a great number of players and many, many different shifting needs is a It's just a different way than the old just create a power plant and create energy. It's not a product, it's a solution, and it's changing all the time. And obviously, supply chains have to respond to this. And supply chains are, of course, in themselves an excellent examples of platforms that respond to shifting needs and are integrated systems with a huge number of players. So a very important point here is the word system. Because when things are integrated in a system, you have to think differently than when you create a standalone product. Things are not as simple as they used to be. Luckily, there is something called systems thinking, which is basically the science which tries to describe the behavior of systems, because systems have ways of evolving and ways of behaving that are very, very different once a system becomes complex. And that is exactly the situation that we will be facing in so many different areas. The old idea of how does stuff work would be the machine. You would have this machine. It would be, if you turned it up a bit, it would go a bit faster. You could disassemble it and look at the individual parts. And basically, you could predict how the machine would behave, and you could basically run it forward or backwards. It would be completely the same. But that when you're looking at a supply chain or Power 2X or mobility as a service, things get really, really tangled and messy. So the idea of just a clean, nice machine doesn't really work anymore. You have to think in terms of systems. So systems are complex. There are many players, and there's a great speed. There's a lot of interaction going on at the same time. And there's a great deal of interdependence, and you cannot predict what's going to happen. It's just the way that complex systems works. This doesn't mean that you cannot predict at all what's going to happen, but you can only say what's going to happen with a certain probability. So we don't know for certain what's going to happen. And that's just the way life is also. But that's also a way of thinking about our business, about our supply chains, that we face uncertainty and we have to think in terms of probability. Another element that you might learn from systems theory, and I can only say, have a look at it, it's a very, very good language for describing complex processes. Positive feedback, when the stock markets go wild, or you have shitstorms on the internet, or the economy suddenly dips into a depression. Or you could have negative feedback, which is inertia, where any kind of change is met with resistance, and you can't get anywhere because there's these loops that resist any kind of change. And finally, the idea of tipping points, which is really important in the context we're in today, that when a system comes beyond a certain point, it'll try to drag the entire system back into normalcy. But at some point, it's not possible to do that. And the system changes, and you have these tipping points where suddenly everything becomes different. And of course, this is what we're all fearing with climate change, that we will get beyond some kind of tipping points where it's irreversible and we change into a complete different logic because the system can't keep working as it used to do. I'm mentioning this because I think that in business, I think we can learn a lot by using these kinds of concepts to describe and also to imagine what we're facing when we're dealing with a huge number of players and a greater integration into complex systems. I guess the ultimate example of a complex system would be an ecosystem. And I know that a lot of businesses already talk about their ecosystem of suppliers or the ecosystem of manufacturers or customers, that you're part of an ecosystem. But I think we can actually find more inspiration simply by looking at the way that natural systems work. Because I think what we're facing is that we also need to develop an economy that works much more like a natural system. And I'll come into some examples here. Some of the mechanisms that are completely ingrained in natural systems would be something that they have a certain resilience. They can handle change and jump back. Natural systems are circular. They're regenerative. You can deplete the resources and the resources will be regenerated. Everyone in the system is interdependent. That's what it is in an ecosystem. There's symbiosis that you strengthen each other by working together. And then finally, of course, there is the evolutionary mechanism that you have to be able to adapt to a changing world all the time. Otherwise, you will perish. So I'll just go into a few of those concepts. But I think a really important one when we think about supply chains and value chains is the idea of resilience. We've seen it in a number of disruptions with the COVID and now with the Ukraine war. And we will see this time and time again, that if you have a system with no redundancy, where it's completely optimized, where you have where all the players are specialized and you have you've tried to make the chain as efficient as possible. The problem with it is that if one of those points then suddenly falls out, you're in deep trouble. And this was the idea that Martha was alluding to, also the idea of a distributed system that can handle changes by rerouting the needs. I think there's a lot we need to think about restructuring value chains into becoming more resilient, because otherwise it's just going to be too expensive for all of us, and it's too unpredictable and dangerous, basically. And the problem here, of course, is that in a machine sense, when you think everything is predictable and it just keeps on rolling, you wouldn't want to do that, because you are in a competitive advantage if you reduce redundancy and you optimize and you get rid of everything that's not supposed to be there. But I think the thing we can learn from nature is that there is a short-term perspective. Of course, we're in a competition in the short term, and we can find advances. But there's always the long-term perspective, and that long-term perspective is built into the way that nature works, that we find again and again that nature has a redundancy that means that everything does not collapse. And one of the things that you can do is you can create diversity in your supply chain, of course, which is great, but also have backups, have alternatives, have a greater a number of suppliers that can take over if someone should drop out. Another very important thing here is the idea of moving from a linear and extractive economy into a circular economy, because basically nature is circular. And I think a really important point in terms of value chains again is that if we truly want to go to a circular economy must be local. I mean, you can think about it. It doesn't. If you want to create closed loops, it's much easier the closer you are, basically, rather than having stuff flown over from faraway countries and global chains spread all over. If you want to create a tight loop, you need to keep it local. And I think this is a basic fact of life that will be reflected in the products and in our supply chains and in the way that we consume generally, which of course has great implications for your work. And of course, the idea would be that not only are you circular and not damaging anything, but in nature we can see that the more life there is, the more action there is in a rainforest, the more that's happening, the stronger the entire system actually becomes. So by your action, you're actually strengthening the entire system, and you're creating, you're giving back and you're regenerating rather than just extracting from the system, which again is a different concept from normal economy, but it's a no-brainer in nature. Final point here about nature would be that in nature there are boundaries. There's an idea of the planetary boundaries where there are certain limits to how much we can extract and use from the system, unless we want the system to reach a tipping point where suddenly it collapses or turns into something different that is not very good for humans. So you need to have a certain balance. And I think this will be reflected in the fact that we can't keep on consuming so many resources that we are doing right now. I think we will have less material consumption. It will be much more problematic to increase material consumptions because we're already at the thresholds in many respects. So I think if you're thinking about supply chains and value chains, I think that less material is a demand, less drain on natural resources. It's just the way that business needs to work in the coming years. So what I've said, I'm sure sounds like of course no-brainers, but I think it's worth contrasting with the way that we conduct business today. What is business as usual? Well, business as usual is not like a natural system. Business as usual and the logic that permeates all of your work probably is that we are still in a linear economy. We just discard stuff. We think about the short term and we have to compete in the short term. There's a capitalist system of infinite growth, and it's very hard to escape. And we still have this idea that the Earth is flat. It doesn't matter where we are. Geographies have been suspended. I don't think they have. And we're trying to optimize and eliminate redundancies and standardize. All of these things, I think we will have to start questioning because it's different now. This is a different world. Technologies are different. We have new ways of overcoming and dealing with the complexity, but also the constraints that we're facing are at a point where it's just becoming unbearable. And days look normal, but we all read the media and we can see what's going on. I think if we want to avoid the tipping point, I think we have to think differently about our place as businesses in shaping the world. So just two final advice here. I think if I were going to two rules of thumb would be that I think atoms, that is physical objects, it's energy, stuff that's made out of the physical world. I think all of that will become more local. We will see a regionalization of the global economy. We'll see a localization of regional value chains. We'll move closer because it's a circular economy, and because you get flexibility, you get speed to customer. Things become more manageable, and then at the same time, I think bits are not a drain on the economy or on the ecology. I think we will use the digital data in order to exchange ideas and designs and understanding of the world. And this we will use in order to actually save the bits. So let me just give an example of this. This is a company called Iveldi. And what they do is, their motto is send files, not parts. And they deliver services for the maritime industry, where sometimes something on a ship will break, and usually will be a problem because the ships can be all over the world, and you need to get that spare part to them very, very quickly, and it's really expensive and it's disruptive to everybody involved. So what they have is they have established a network of 3D printing partners that have 3D printers that live up to certain technical specifications, and they can send the the file that describes the spare part that is broken, and they can send it to the nearest 3D printing station, and then the ship can get the spare part very quickly. And I think this is, of course, an extreme situation because there's so much money at stake. But I think exactly the same will be the case for all kinds of spare parts, or for shoes, or any consumer object for that matter. That I think the model that there will be a digital pool of designs that we can access from anywhere, and that we will have 3D printers, we will have the equipment to print out the object closer to us. Of course, that is a disruption to the value chain, but I think this is what nature will demand, and also it just makes a lot of sense. One interesting thing about this is that if you look at something like fermentation, which right now is the way that you produce wine or beer or bread, but which can be used in the way that you program a microorganism to create a certain protein. It could be medicine, it could be energy, it could be plastic, it could be dairy products. It could basically any substance that nature produces. You can create, and you can even gene edit a sequence, and then you can send that in digital form anywhere you want, or you could download it, and then you can synthesize that sequence, put it into a microorganism, grow that microorganism in a culture, and basically make any very, very advanced and very specific molecule wherever you are, with a process that is very reminiscent of brewing beer. I think that is another example of how complexity now becomes available globally without having to ship it around. And one example of this is BioNTech that